Hey there, Year 11s. We are now looking at finding the derivative for example over here. Notice this is Leibniz notation, and what we're doing here is we're finding the derivative of y equals to t squared. So how do we do this? Y equals to t squared. Unlike, it's slightly different to f of x, but same thing. Usually we do f dash of x and then use the power rule where we say it's 2t to the power 2 minus 1, and that gives you 2t, right? Well, in this case now, we write delta y delta x, which is the same thing, means that you'll find a derivative, and again, it's the same thing, 2 times t to the power 2 minus 1, and that gives you 2t as well. So both of them are the same, they're just different notations. Meaning the same thing. Delta y delta x just means change in. So some of you might have been used to seeing it as delta. So you can write delta y and delta x as well. That means the same thing as well. Okay. All right. So I'm just going to rub this out so it doesn't get confusing. So A, we found it to be delta y delta x is equal to... sorry, not delta t, delta x is equal to 2 times t. Then let's look at part B. So in part B, what do we have here? We've got x is equal to t cubed. And notice the notation here. It is the change of x with respect to t. And that's trying to get you to understand that this is obviously the term that we're interested in. We normally call that the dependent variable. Okay, or the output, and then this is obviously the independent variable. So we normally say it's delta x with respect, which means to, it depends on whatever t is, so with respect to t. So in this case here, when you write delta x delta t, you know that you're differentiating a variable of t, okay? So that means, again, it's 3t to the power 3 minus 1. So I'm using a power rule because this fits the power rule. It's a polynomial function, and that gives you 3t squared. Okay, so it's just learning how to read the notations, what this exercise is trying to get you to do. So in part C, in this question here, we now have z. Okay, so this would be a function with z in terms of x. So you would then say delta z with respect to x. Okay, so here we go. Z is equal to 1/3, so that's the coefficient, multiplied to x cubed, which is a polynomial, plus you've got an x squared, which is another polynomial. So when you find delta z, and delta x, probably I should write it as like that. Nah, I'm used to writing my little z's like this. Okay, is equal to, again, 1/3 is not what we're interested in. We're differentiating the power function. So here you would essentially say it's 1/3 times, and it's 3x to the power 3 minus 1. And then same thing again, plus, and we're differentiating the function. Okay, so the function would then be 2x, sorry, let me just fix that. 2x to the power of 2 minus 1. So when you write it out, this now becomes delta z delta x is equal to 1/3 times 3, which is 1, and then x to the power 3 minus 1, which is 2, plus 2x to the power of 1. And there you go. That's my derivative when you're using Leibniz notation there. It's essentially still finding the derivative, but just being mindful what happens where you write the delta x or delta t. That's really what the function is in terms of. It's in terms of t, so it's delta t. This is in terms of t, so it's delta t. And this is in terms of x, so it's delta x, okay, in the denominator. I hope that helps.